Hey, so in the last two videos, what we did is we calculated the Riemann sum from the left endpoint, and we calculated the right Riemann sum. And now, in this third video, we're going to calculate the middle. We're going to calculate from a midpoint to see if that gives us a better estimate of the area under this curve. So we have our polynomial x squared plus 1 that we're estimating. We want to estimate the area under the curve using three rectangles on this interval 0 to 6, and we just chose arbitrarily to break it up this way, right? We could have broken it up into 100 different rectangles. That'd be a better estimate, but that's a lot more work, right? To write out 100 rectangles. So for this demonstration, we just have three rectangles we're using to estimate this area. So first, let's look at the difference in how we're calculating the height. So in the first video, when we calculated the height, we were doing the right Riemann sum. So we have these three subdivisions. And so when we did to do a right Riemann sum, you calculate the height from the right endpoint, right? So like if we're just looking at this first one, we would have calculated the right from the right endpoint. The left Riemann sum was calculated from the left endpoint. Now in the middle, we're just calculating from the midpoint of these two, the middle of the left and the right. So we could average those, but in this case, it's pretty easy to see that like the middle of 0 and 2 is 1. So first, let's calculate this height at 1. So f of 1 is going to be, let's just do it out. F of 1 is 1 squared plus 1 is 2. So this height right here is going to be 2. And then let's see, so we'll do the second one. So the height is going to be, we're taking the height from the midpoint, which is 3. So we'll get f of 3 is going to be 3 squared plus 1 equals 9. So this height here is 9. And then for this third rectangle, again, using the middle point, we'll calculate f of 5 in this polynomial, which is going to be 5 squared plus 1 equals 26. So our height of this is 26. Then calculating the area of these rectangles is just going to be height times width. So, and the width of each of them is 2, right? We did it with a standard width. So width 2 times height 2, this area is going to be 4. For the second rectangle, width of 2, height of 9 is going to be 18. And then for this third one, width is going to be 2. For a second, I thought I did something wrong. Yeah, the width of this third one's going to be 2, and then the height is 26, so this is going to be 52. And so then we can just add it up to get our area. So our area is going to be 52 plus 18 plus 4, and that's going to be 74. That's interesting because, so in the first, when we did an estimate, we'll just go over our estimate by using a right endpoint was 118. From the left, it was 46. And now in the mid, we get a middle value. Okay, so that's the middle Riemann sum. Haven't decided. So I think in the next one we'll do a trapezoid. Okay, so that'll be a different way to calculate, where instead of calculating rectangles, we actually do it as a trapezoid. And then we can also compare it to the actual integral. So I'll stop it there.